Okay, so today we're going to be moving on to chapter 4.3 in our textbook, which is all about dividing polynomials. This is probably the most complicated thing we're doing for at least a little bit in this chapter, but it's also one of the most important because we're going to build on it later. So I would definitely be taking notes here and make sure you're paying attention, getting this, and if you're not, be sure to ask questions. But if there's one assignment that you're going to do on time for this unit, I would recommend it being this one because this is going to be some of the slightly more confusing stuff if you don't know how to do it, and it'll make everything else harder for the rest of the class. So definitely practice this one. But to start, we're going to start with dividing by monomials, which you probably already know how to do basic division by monomials. For instance, 3 plus 7 over 13 simplifies to 3 over 13 plus 7 over 13, which is equal to 10 over 13. That's just basic fractions. Hopefully you guys know how to do that. But we can also divide monomials that contain variables. So let's look at the problem, 3x to the fourth plus 5x cubed over 5x cubed. We're going to start by doing the exact same thing we did in this division, which is break it into two parts. So we'll have 3x to the fourth over 5x cubed plus 5x cubed over 5x cubed. Now, this one to the right is super easy. You have a number divided by itself, 5x cubed over 5x cubed. That simplifies to 1. That one's pretty simple. This one's a little bit tougher, but if we remember what exponents actually mean, 3x to the fourth is the same as 3 times x times x times x times x, and 5x to the third is 5 times x times x times x. We can cancel these. Can't really do anything with the 3/5. You still have 1x left on the top. So this is equal to 3 over 5x. And then we add in our 1, and this would be our solution. So let's look at another example. This time we have 6x cubed minus 3x squared plus 2 all over 2x squared. I'm going to do the exact same thing we just did. So 6x cubed over 2x squared minus 3x squared over 2x squared plus 2 over 2x squared. So first one, we're going to cancel the 6 and the 2. We're going to get 3 and 1. And then x cubed will cancel with x squared to get just x. Right, x times x times x over x times x. You cancel 2 of them, you're left with 1 on top. So this gives us 3x. Then we have 3x squared over 2x squared. Cancel the x squareds, can't do anything with this, so we have minus 3 over 2. And then this one here, we can cancel the 2's, but then we're left with 1 over x squared. And in this case, this is actually not an issue. Normally, you don't really want to keep variables in your denominators. It makes things kind of a pain. But for our purposes, that's perfectly okay when we're doing dividing by polynomials or monomials. So this would be our answer to this problem. The key thing here is to remember that you must divide every term in the numerator by the denominator. So you'll notice that we have this x squared in the denominator on the last one. Anytime the degree of your denominator is greater than the degree of something in your numerator, you're going to have an x in your denominator somewhere. That's not an issue for this chapter. You don't have to worry about that. If you end up with an answer like we'll see in the next one that has x values in the bottom, you don't have to do anything to simplify it. So now we're going to move on to dividing by polynomials, which can be really tricky, so please be careful. Pay attention, and you're going to want to do this the long way most of the time. So we have divide 2x cubed minus 3x squared minus 11x plus 7 by x minus 3. Now, the first thing we want to do, every time we're going to be doing this, we're going to ignore the minus 3 to start. So in this case, we want to figure out how many times x goes into 2x cubed. And the answer to that is 2x squared. But now we need to, like we do in log division, multiply this 2x squared by the whole thing here. So 2x squared times x minus 3 is 2x cubed minus 6x squared. And then we're going to subtract. So we subtract these down. 2x cubed minus 2x cubed is 0. 3x squared, or negative 3x squared, minus negative 6x squared. So negative 3x squared plus 6x squared is 3x squared. There's nothing to subtract here, so we have minus 11x, and then we have plus 7. Now we need to do the same thing. How many times does x minus 3 go into 3x squared? The answer to that is 3x. When we multiply that out, we get 3x squared minus 9x. Which once again, we subtract. These are gone. We have negative 11x minus negative 9x. So negative 11x plus 9x. That's negative 2x plus 7. So how many times does x go into negative 2x? That's minus 2. Negative 2 times this is negative 2x. Negative 2 times negative 3 is plus 6. So we subtract. Again, these will cancel. We have 7 minus 6, so we have 1. X minus 3 can't go into 1, so we're going to have just plus 1 over x minus 3. So our final answer will be 2x squared plus 3x minus 2 plus 1 over x minus 3. And this has a cubed here, which it shouldn't, but what we should end up with is 2x squared plus 3x minus 2 plus 1 over x minus 3. Now, we could multiply these whole things out together to prove that this is what it simplifies to, but honestly, that takes a lot of time, so I'm not going to bother with it. If you want to see me work these backwards to prove that we have the right solution, I can do that, but it's just going to be factoring it. So we take this whole thing, put it in parentheses, and multiply it by x minus 3, see what we get. And that will take a lot of time, so I'm not going to bother with that right now. More division of polynomials. Got another example. This time we have 6x squared plus 5x minus 10 divided by 2x plus 3. So first we need to figure out how many times 2x goes into 6x squared, and that's 3x. So if we did this individually, cancel, 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 we're left with 3x on top. 3x times 2x plus 3 is 6x squared plus 9x. We're going to subtract these. We'll get 0 minus 4x minus 10. 2x plus 3. 2x goes into negative 4x, negative 2 times. 2x over 4x. Whoops, I did it the wrong way. Negative 4x over 2x. X's cancel. This reduces to negative 2. So negative 2. Negative 2 times this is negative 4x minus 6. Subtract these down. These cancel. We get negative 10 minus negative 6. That's negative 4. So our remainder is minus 4 over 2x plus 3. Now, when you look at this top factor, you might be tempted to try to reduce by dividing both of these by 2, but then you'd have to divide 3 by 2 as well, and that doesn't work. So unless you can divide it by everything, you're not going to simplify this at all. So in this case, we have 3x minus 2 minus 4 over 2x plus 3. Now, if you want to, and this answer does down here, you can also write this as plus and then the negative number over the 2x plus 3. That's fine. It doesn't really make much of a difference. It's just if you end up getting a negative value because of your x, it could confuse people sometimes. So either way of writing this is fine. It doesn't actually make any difference here. The last one we want to look at is a little bit more complicated. We've got this x squared in our divisor. So this time we have 5x cubed minus 4x squared plus 7x minus 2 divided by x squared plus 1. So the first thing is we want to figure out how many times x squared goes into 5x cubed. That is 5x. Now when we multiply this, we need to be careful. We're going to get 5x cubed when we multiply 5x by x squared. But then when we do the plus 1, we're going to get plus 5x. Personally, I would make sure you line it up correctly, because if you put it here, you might be tempted to subtract down, and then you're going to get a weird answer. So if we subtract these will cancel. This should be a 3, sorry. These will cancel, and we have 7x minus 5x, so that's minus 2. Or whoops, that's just plus 2x. Minus 2. We can bring our minus 2 down. There's nothing for the x squared yet to mess with, so we're going to do 4x squared. Leave that with the same symbol. And then we need to do how many times does x squared plus 1 go into negative 4x squared? The answer is, of course, negative 4. Then we need to multiply that out. We'll get negative 4x squared minus 4. And again, you'll notice we have to leave a gap here. Otherwise, we might subtract the wrong thing. So we subtract these will cancel. Negative 2 minus negative 4 is 2. And then our 2x we can just bring down. So now we have 2x plus 2. X squared doesn't go into this at all. So this whole thing right here is going to be our remainder. And that's going to go plus 2x plus 2 over x squared plus 1. So our final answer here is going to be 5x minus 4 plus 2x plus 2 over x squared plus 1. That's going to be our solution there. All right, the last thing we want to talk about today is synthetic division. Now, synthetic division is a shortcut to doing division by polynomials, but it only works in specific situations, and it can be very tricky and confusing. In fact, if I'm being honest, I had to restart this lecture because I messed it up the first time, and it looked really bad. So this time we're going to get it right, but I would only recommend doing this if you're super comfortable with doing it the long way, if you're super comfortable with this shortcut, and if it actually fulfills the criteria, which I'll talk about right now. So the shortcut to dividing polynomials only works when you are dividing by x minus k, where k is any constant. Now, if k is a negative number, that will give you an x plus. So like x plus 2, you can still use synthetic division to divide by this. Just remember that whatever symbol you have here is going to get flipped when you're determining your k. Right? That's going to be really important, and I'll talk about it on the next slide when we go through an example. What I'm going to do on this slide, though, is I'm going to tell you all of the rules for doing it, which won't make a lot of sense until you see an example. So I would recommend writing them down so you can reference them while you're doing it. The first step is to write k as a separate term to the left, and then fill in your coefficients in a line to the right. Add a second row, but leave the first space blank. Add row 1 and row 2 to find row 3. Multiply the result from above in your next spot on row 2 and repeat. So this is multiply the result by k. So multiply your result from this step here by k to fill in your next spot on row 2 and repeat. The numbers of row 3 represent the coefficients for your resulting polynomial, and the last number represents the remainder. The power for each x value should be reduced by 1. So I would write all these things down. You'll probably want to pause the video, and then I'm going to go through the example here right now. So here's the example. We've got 3x to the fourth minus 7x cubed minus 4x plus 5 divided by x minus 2. Now remember, we have an x minus k. In this case, our k is just positive 2. We need to flip this symbol every time. So k is 2. We're going to write that over here to the left. And then usually what we do is we put a little box down here to keep it separate. Then we need to do all of our coefficients. Now, this problem is tricky, and the part that slipped me up was you've got a 3 as your leading coefficient for your x to the fourth. Then you have a minus 7 for your x to the third. There's no x squared value, so your coefficient here is going to be 0. You need to add that in when we're doing our coefficients. Then you've got a minus 4x, and then you've got a plus 5. So we've got 3, we've got negative 7, we've got 0, we've got 4, and we've got 5. Then we're going to leave room for a second row. That's going to go here. We don't do anything on this first one. We just bring down the 3. Okay, so that step is pretty easy. Now we need to take our row 3, multiply it by our k value, which is 2, and put that in row 2. So we have 6. Then we need to add. So all of these are going to be added. Negative 6 or negative 7 plus 6, that's negative 1. Negative 1, again, times 2. That gives us negative 2. 0 plus negative 2, that's negative 2. Okay, negative 2 times 2, that's negative 4. Now, and this time, 4 plus negative 4, that gives us 0. Did I mess something up again? Yes, I did, because this should be a negative 4. Sorry. This is a minus. It's my bad. I put that in wrong. So this should be negative 8. Ignore that last step. Then we do negative 8 times our k value, which is 2. So this should be negative 16. Here, let me erase this actually. Nope. Sorry, guys. As you can see, it's very important to get your coefficients correct here. So sorry, negative 4 plus negative 4, that's negative 8. Negative 8, we multiply by k, we get negative 16. Add these together and we get negative 11. Now, since there's nothing else to do here, we don't need to add anymore. So our final problem is going to be all of these with negative 11 being our remainder. In this case, what that means is we're going to have 3x, and then we're going to reduce our coefficients by 1. Our first coefficient was 4, so this is going to be a 3. 3x cubed. Then we have minus x squared, minus 2x, minus 8, minus 11 over x minus 2. This should be our answer here. And we get 3x cubed minus x squared minus 2x minus 8 plus, and they said plus negative 11 over x minus 2. You can do minus 11 over x minus 2. They're the same thing. Now, we can also do this by a long division if you wanted to. And if we do that this way, I'll show you just to show you that you get the same thing. 7x cubed minus 4x plus 5 divided by x minus 2. So first off, x goes into 3x to the fourth, 3x cubed times. That leaves us with 3x to the fourth minus 6x cubed. Subtract these down. These will cancel. This gives us negative 1x cubed. Negative 1x cubed goes into x minus 2 goes into negative x cubed. Negative x squared times. So we'd have negative x squared times this. That's negative x cubed. Here's our minus 4x plus 5. Now, the key here is to remember that there's this 0x squared value that you need to have, because if we multiply negative x squared by this, we're going to get plus 2x squared. There's not really anything to bring that down. So if we throw in our 0x squared really small right here, you can subtract those. These cancel. And we're left with negative 2x squared minus 4x plus 5. X minus 2 goes into this. Negative 2x times. That gives us negative 2x squared. And then negative 2x times negative 2 is plus 4x. Bring down the 5. Don't bring down the 5 yet. Subtract these, cancel. Negative 4x minus 4x, that's negative 8x. And then you've got plus 5 here. That x minus 2 goes into negative 8x, negative 8 times. Negative 8 times x minus 2 is negative 8x plus 16. Subtract these. These will cancel. 5 minus 16 is negative 11. And then we have negative 11 over x minus 2. So it gives us the same thing that we got before, but the synthetic division went a little bit faster. So the last one we're going to go through is this 2x cubed plus 4x squared minus x plus 5 divided by x plus 2. Remember that this is x minus k, which means we need to flip the symbol. So we're going to have a negative 2 over to the left this time. Then we're going to write out all of our coefficients. This time they actually give us all of them. So we've got 2, we've got 4, we've got negative 1, and we've got 5. We're going to start the same way, bring this down. Then we're going to have 2 times negative 2, that's negative 4. We add these, we get a 0 here. And then we multiply by negative 2, which gives us 0. We add these, we get negative 1. Negative 1 times negative 2, that's positive 2, so we should have a 7. So that means that our final problem should be 2x squared, our final solution. And then we're going to have plus 0x. We're going to get rid of this at the end, but I'm writing it out right now so we can see it. Then we're going to have a minus 1 and then plus 7 over x plus 2. So 2x squared minus 1 plus 7 over x plus 2. And that is, in fact, our answer. I believe, yeah, that's it for this video. Like I said, this stuff is pretty complicated. So if you don't understand how to do it, don't panic, but do ask for help and make sure that you try some problems on your homework. This is definitely something that takes some practice to get used to and isn't going to be super simple right off the bat, but hopefully we can get everybody through it before we start adding stuff to it in just a little bit. But I think that's it for this one. So I will see